cubic to start with. To factor anything, you need to know the intercepts. You need to know the x-intercepts, really. Well, there's a common factor between these three, and it's x. One thing to note about the CSET is that you're always getting quadratics popping up in different contexts. So maybe you're used to seeing quadratics in certain lights, but they're popping up in all kinds of random questions. Supposedly it's a cubic question, but really we're just going to do a little quadratic factoring here. So what we notice is x minus 4 and x plus 2. Well, now that we've factored this out, we know what our roots are. Our roots are x equals 0, 4, and negative 2. So these are all roots of p of x. If we were showing our work, how would we explain that these have to be roots of p of x? Well, we would have to cite the factor root theorem, which by now you guys should have memorized. And we already did that with our 1.2 work. So I'm going to assume that it's memorized, but next to it, I'm just going to write FC, where we would have to state our flashcard idea. Remember, it's going to be a matter of stating and then applying. So you state with the generic, and then you apply to the specific. And the flashcard idea would basically be stating your, and I call it factor root theorem. The idea being if x minus r is a factor, then x equals r is a root of the polynomial, and we would then apply it to this. So, one other thing is we have our x-intercepts, and what's our y-intercept? Well, for the very beginning, any polynomial function, the constant at the end is going to be the y-intercept. And since we don't have a constant here at the end, we know our y-intercept is just 0. So, straight away, we can graph this. We have 0, 4, and negative 2. Now, you're looking at the positive lead coefficient. That means it ends positively. If it's negative x cubed, it would end negatively, okay? I don't start graphing it from this side. I start from large x values, okay? So we're here, and then it goes back down. I don't know exactly how far down it goes, and you know what? CSET people don't care, so I don't either. And it's going to go back up something, I don't know. If I had to get some ballpark estimate, I'd plug in negative 1. That's not going to be the highest potential value, but it gives you an idea of roughly how far up it goes. All the CSET people are looking at, does it end in the right place positively because it's positive x cubed, right? And since it's positive x cubed, it should be ending up there. And does it go through the 3 appropriate roots? Yes, it does. Right? So this is the graph of p of x. We had to label all intercepts. There are no asymptotes to talk about, so this is part A done. All right, now, if we're doing part B. If we are doing part B, what we want to think about is 1 over this entire thing, right? Because g of x is really just 1 over. And I could do this form, which is not factored out. But I think the much better form is where it's fully factored on the bottom. And what we see is, with the rational functions, on the bottom, you set that equal to 0, and that gives you the discontinuities. And what the discontinuities really represent are the vertical asymptotes. So, essentially you set the bottom, or the denominator. I always say tops and bottoms. I have since I was like a kid. I have no clue who would really say numerator and denominator. No, tops and bottoms. Come on, get it straight. Now, set the bottom equal to 0, and that gives you your vertical asymptotes. Notice I said vertical asymptotes, not all the asymptotes. So how do you get your horizontal asymptote, Justin, since you hinted at it? Well, the horizontal asymptote, what you're going to think about is you're going to think about for really large values of x. All right, so always to get your horizontal asymptote, you can think about really large numbers of x. Think about the value of the function as, think the value of f of x as x approaches some really big number, like negative infinity or positive infinity. But we don't really need to go that far, because that's approaching some real math. Let's do back over here a little bit of dirty math, just for common sense. That's the real idea. All you think about is just plug in x as 100. Right, that's big enough. Now, what you get is 1 over 100 times 1 over 99, right? And then 1 over 102. Well, 100 times 100 times 100, roughly, it's a pretty big number. 1 over a million? 1 over a million is really, really small. So 1 over a million is basically 0. So your your horizontal asymptote is y is going to be 0 as x approaches infinity. That is our horizontal asymptote. Y equals 0 is our horizontal asymptote. So we have everything we need, except for more space. So I'm going to now crank it down to finish the question. And to finish this question up, I'm going to go ahead and go right back in here. So we have our vertical asymptotes, and then for our horizontal, we have y equals 0. So x equals 0, x equals 4, and x equals negative 2, we have vertical asymptotes. Well, graphing this now, we get a negative 2, 0, 4. Let me get a little purple to make it pop. So we have dashed line, and a dashed line, and a third dashed line. We have our horizontal asymptote as well. Now visually what you're going to see is it's either going to go up, down, or it's going to go down, up, down, up. We plug in a number in each range to just think about it. I'm going to start with 1 because it's the easiest number to plug in for me. 1, positive. 1 minus 4 is a negative. So I'm plugging in x equals 1. And it's just a positive, and then 1 minus 4 is a negative. And then 1 plus 2 is a positive. So overall, it's a positive over a negative. That gives me a negative. So for x equals 1, I know I'm going to be negative. And I'm down here, and you never cross the asymptote, so it's just going to hook right back down. Now once I've plugged in one value, I already know the others are going to fit this form. And it's going to go up. I don't know exactly how far down it goes. All I need to show is that it doesn't touch the axis. That's all I need to show. And then eventually it goes towards the asymptotes, and there we have our shape. So, fulfilling the question, there are no asymptotes to a label. There's x equals 4, x equals 0, and x equals negative 2. Then the horizontal asymptote is y equals 0. There are no intercepts, and I believe I have the entire question in. All right, so this question, very similar, has popped up. I've done the first two parts. I haven't done the third part. Go find the third part. I'm going to do it on a separate video. And go ahead and do your follow-up question. This is constructor response insight question on 1.3. All right, we're doing 1.3 right now. And if you understood this, please do the two follow-up questions. This is almost a guaranteed concept on your CSET.